Hello students, welcome to my class. In my last lectures, I was discussing about the theories related to D and F block element. Today, we will discuss few questions related to this topic. So, let's start. Okay, look at. I think now you have a good hold on this chapter. So, look at what is given here. Read the question carefully, my friend. To what extent do the electronic configuration decide the stability of oxidation state in the first series of the transition element? Illustrate your answer with example. Clear, my friend? Now, listen carefully. To what extent? Yes. For a particular oxidation state, if the electronic configuration is nearest inert gas like configuration, if the electronic configuration is like nearest inert gas configuration, or half filled electronic configuration or half filled d subcell electronic configuration or full filled d subcell electronic configuration, then what we find, that is, these are the case of stability of that particular oxidation state. For example, I am giving you example, wait for a moment. Now, if I write here Mn, yes sir, Mn atomic number 25, yes, definitely. It has electronic configuration argon 3d5 4s2. Now, if it lose the 4s electron, then what will happen? It comes to the oxidation state Mn2 plus. Now, the electronic configuration is argon 3d5. Now, if it lose one more electron, then it comes to the Mn3 plus oxidation state. Now, it is argon 3d4. Now, if it is losing one more oxidation state, then what will happen? That is argon 3d3, so on. But what we observe here, if I compare plus 2, plus 3 and plus 4 oxidation state, what we get here, that is in plus 2 oxidation state, the electronic configuration is 3d5. This is the half filled d subcell. If the half filled d subcell, then it is more stable than the partially filled d subcell. So, we can say Mn in plus 2 oxidation state is more stable than plus 3 and plus 4 oxidation state. This is the case, my friend. Now, if I write here Zn, atomic number is 30. It can be written like this, argon 3d10 4s2. Now, if Zn is in plus 2 oxidation state, then what do we observe here? That is argon 3d10, my friend. It loses 4s plus electron. Now, it has full filled d subcell. If it has full filled d subcell, then what do we estimate, my friend? That is the case here, it is plus 2 oxidation state, my friend. Plus 2 oxidation state is stable. So, this is the complete description of this question. Though it contains 1 marks, but maybe they can change the weightage of the question. So I have given you the complete information. Now let's move to the next one. The next one is, my friend, that is the question number 2. Wait for a moment. That is the answer of this question. Listen. Which metal in the first transition series show +1 oxidation state most frequently? Yeah. As we know, copper 29, it has electronic configuration argon 3d10 4s1. Now it has only 4s1 electronic configuration, so it can easily lose this 4s electron and will convert it to, that is, copper plus iron. That is the geometry, the electronic configuration here, that is argon 3d10. So copper is the answer, which easily show +1 oxidation state, and after losing the 4s electron, the configuration comes Ar3d10, and d10 here what? Completely filled d subcell. Clear to you? Completely filled d subcell. Am I right? Yes. It can show the +2 oxidation state also in aqueous solution. Here it will decide by the electrode potential value and the hydration value. I have discussed this thing, but here only they are asking which oxidation state is which transition series can show +1, that is the copper answer. Simple explanation. Clear? Now I am going to rub this part and we will discuss the next question, my friend. Now what is the next question? Listen carefully. This is the question number 3. Read the question. What is lanthanoid contraction? This is a good question and important question. What is lanthanoid contraction and what are the consequences of lanthanide contraction? As we know, if I talk about the atomic number lanthanum, that is lanthanide, cerium 58 to lutetium 71, that is total 14 elements. Clear, my friend? 58 to 71. Clear? Now what do we observe when we move from cerium to lutetium? Then there is a regular decrease. There is a regular decrease in the atomic and ionic size and the ionic size. The regular decrement of ionic and atomic size when we move in the lanthanide series, that is from 58 to 71, due to the increase in the effective nuclear charge value. And why there is an increase in the effective nuclear charge value? Due to the poor shielding effect or skinning effect of F subcell, and is known as lanthanide contraction. Again I am repeating, the regular decrease in atomic and ionic size in the lanthanide series when we move from cerium to lutetium is known as lanthanide contraction. What is the reason of lanthanide contraction? As we know, when we move down the group, there is a addition of an electron. There is a addition of one electron take place in each step, and it enters into N-2 F subcell, that is anti-penultimate subcell, and F subcell has poor skinning or shielding effect. Due to this reason, there is an increment in the effective nuclear charge value. If there is an increment in the effective nuclear charge value, then what we observe here, my friend, we observe there is a decrease in size. But the decrement in size is not very large. The difference, there is a small decrement in the size. Clear? What are the consequences of lanthanide? First consequences, what we observe due to lanthanide contraction there is a decrement in size take place, but the decrement in size is very small, that is there is no large difference in size between two elements of lanthanide series. Due to this reason they all have almost equal chemical properties. This is the first consequence. Second consequence, due to lanthanide contraction, when we talk about the 4D and 5, when we discuss the atomic and ionic size of 4D and 5D series, what we observe, as we know, when we move from 3D to 4D size increases, but when we move from 4D to 5D, what we observe, they have almost equal size. For example, if I talk about zirconium and hafnium, they have almost similar size, around 160 picometer. It is also a value around 159 picometer, and they have equal size because they due to lanthanide contraction. Now the third consequence is, as we know, when we move down the group, the basic character, the basic nature of the hydroxide of lanthanide series, which is EOH whole thrice, decreases, because due to the decrement in the size the covalent character increases, and covalent character, that is the basic character, decrease. This is the three consequences of the lanthanide contraction, my friend. Clear? Check it out. Now I am going to rub this part, my friend, and we'll discuss the next one. The next question is question number 4. Read the question carefully, what is given here. What are the characteristics of transition elements? What are the characteristics of transition element and why are they called transition element? Which of the D block elements may not be regarded as transition element? This is a small, very easy question. What are the characteristics of transition elements? They form colored compound. Yes, they have high heat of atomization. They are generally hard metal. They have magnetic properties. They have catalytic action also. They form colored compound in solid state, even in aqueous solution also. They show variable oxidation state. They form interstitial compound. They can form alloys. And why they are called transition element? Because they have, my friend, partially filled D subcell. Partially filled D subcell. Due to the presence of partially filled D subcell, they are treated as transition element. Which elements or which of the D block element may not? Last element of each series, Zn, Cd, Hg and Cn are not treated as transition element. Why they are not treated as transition element? Because they have completely filled D subcell. Due to this reason, they are not transition element. Clear, my friend? Yes, sir. Absolutely. You are absolutely right. Now, let's move to the next question. What is given here? 3 marks question is very simple. What is given? Describe the oxidizing action of the potassium dichromate. We all know, during my lecture I have discussed, that is potassium dichromate, that is K2Cr2O7, act as a strong oxidizing agent. Why it act as a strong oxidizing agent? Because in K2Cr2O7, the central atom, that is chromium, is at higher oxidation state, that is +6. Further, it will decrease its oxidizing state generally in acidic medium, sometime in basic as well as neutral medium, but the reaction is more dominant in acidic medium, my friend. That is, what is the relation here? Cr2O7 in acidic medium, that is H plus, converted into Cr3 plus. Clear to you? Here is 7, the balance equation is 7H2O, put here 14H plus. Cr2O7 2 minus plus 14H plus 2Cr3 plus 7H2O, my friend. This proves that is the oxidizing nature. Now the question here, by write the ionic equation, is very simple. When it combined with iodide, my friend, I am moving here. I need more space. Clear? That is, as we know, K2Cr2O7, my friend, when treated with iodide, that is Ki, my friend, the skeletal equation, it will break like this: 2K plus and Cr2O7 2 minus, and this will break like this: K plus and I minus. So what is the ionic equation here? Cr2O7 2 minus plus I minus, it gives you Cr3 plus I2, my friend. And now balance here, that is the medium is acidic, H plus, clear, 7, so put here 7H2O, clear. Now put here, my friend, that is 2, and here 14H plus, clear. Iodine, now put here, my friend, that is 5I2, and here is 10I. Now check out the things here: chromium 7, that is 7H2O, that is 7 to 14, clear, and 7 oxygen, okay, 10I minus and 5I2. This is the balance equation. I have discussed this thing in my lecture also. Now the second one is what will happen in this case, that is iron 2 sulfate. Clear to you? What is given here? Iron 2 sulfate, that is, my friend, Cr2O7 2 minus and Fe2 plus. Definitely it converted into Cr3 plus and Fe3 plus. Fe2 plus will be converted to Fe3 plus. Now if you do not know the balancing, I am doing the balancing for you. Cr2O7 converted to 2Cr3 plus. Now here is 7, put here 7H2O, my friend. Clear? Now overall decrease in oxidation state, tell me. There is a, here is the oxidation state 6, so the decrease in oxidation state, what is the decrease in oxidation state, my friend? That is 6 converted to 3, 2 times that overall decrease in oxidation state 3, that is the total decrease in oxidation state, that is 2 here, 2 moles, that is 2 into 3, that is the 6. Overall decrease in oxidation state is 6. I am moving here, my friend. Now in case of Fe2 plus, Fe2 plus converted to, my friend, Fe3 plus. Now here is increase in oxidation state, tell me. Increase in oxidation state is 1. Now this is the equation 2. Now what is the rule says? We have to balance the total decrement and total increment in oxidation state. So we have to multiply equation 2 multiply by 6 and plus equation 1. Equation 2, that is 6Fe2 plus, and equation 1 is, my friend, Cr2O7 2 minus, that is 2Cr3 plus. Now balance oxygen here, that is 7, put here 7H2O. Now put here, my friend, 14H plus, and here is Fe3 plus also. Now 6Fe3 plus. This is the complete balance reaction. 6Fe2 plus Cr2O7 2 minus plus 14H plus, that is 2Cr3 plus 7H2O plus 6Fe3 plus. Clear, my friend? Similarly, this is the thing here. Now next one is H2S. Now the third one is, as we know, Cr2O7. H2S is H2 minus. Yes sir, definitely, that is, it gives you, my friend, 2Cr3 plus, and sulfur will be converted to H2S converted to sulfur. This is the reaction. Again, you have the theory, you can easily balance by using this method, my friend. Should I do? Okay, wait for a moment. Now Cr2O7 2 minus converted to 2Cr3 plus, that is the total decrease in oxidation state. Yes sir, total decrease in oxidation state is 2 into 3, that is 6. This is the equation 1, my friend. Am I right? Yes sir, because it is in plus 6 oxidation state. Yes sir, absolutely right. Now I am moving here, check it out. That is the case here. This is now next one, H2S, that is sulfur 2 minus converted to sulfur, that is 0 oxidation state. So total increase in oxidation state, tell me, total increase in oxidation state is equal to, my friend, 2. Now this is the equation 2. Now what to do, my friend, in this case? To balance we need total increase and total decrease. Equation 2 multiply 3 plus, my friend, equation 1. Equation 2 multiply 3 plus equation 1, that is Cr2O7 2 minus plus 3H2 minus, it gives you 2Cr3 plus 3S. Clear? Now what to do? Here is 7, put here 7H2O, and now we can put here plus 14H plus, my friend. This is, wait for a moment, that is plus 14H plus, it gives you 2Cr3 plus. Clear? This is the complete reaction related to this question. Now let's move to the next question. Wait for a moment, my friend, give me few seconds. Now what is the question here is question number 6. Predict which of the following will be colored in aqueous solution. As we know, if the substance is colored, that means to say it has partially filled. Colored, that means to say it has partially filled D subcell. Partially filled D subcell. One more thing, if I talk about Mn2 plus, look at it has Mn2 plus, it has geometry 3D5, that is partially filled. If I write here Fe3 plus, that is, my friend, again it is 3D5 because Fe has electronic configuration 3D6 4S2, 3 plus, that is 3D5. Similarly, cobalt has electronic configuration, my friend, 3D7 4S2. Am I right? Yes. Now 3D7 4S2, that is 2 oxidation state 3D7, partially filled D subcell, and due to DD transition, if I talk about scandium 3 plus, scandium has electronic configuration 3D1 4S2, that is it has electronic configuration 3D0. If that is no partially filled, that this one is not colored, my friend. Similarly, titanium, vanadium, they are partially filled. And if I talk about MnO4 minus, here Mn is plus 7 oxidation state 3D0. So what we find, this is also not colored, but we know KMnO4, K2Cr2O7 are colored due to charge transfer method. Here due to charge transfer method, my friend. Clear? Due to, so it's very easy, check out whether they have partially filled D subcell or not. If they have partially filled D subcell, then they are colored. If they do not have partially filled D subcell, then they are not colored. In case of MnO4, they are colored due to charge transfer method, my friend. Clear? This is the thing. You can check every Mn2 plus, Fe3 plus, cobalt plus, MnO4 minus, scandium 3 plus, vanadium, titanium. Clear? Now what is meant by disproportionation reaction? If anyone asks you disproportionation reaction, if a substance undergoes both oxidation and reduction, what I am telling, if a same substance undergo both oxidation and reduction, is known as disproportionation reaction. For example, if I write here MnO4 2 minus, it convert into MnO4 minus plus MnO2. Wait for a moment. Put here 3, put here 2, clear to you, plus H2O, put here H plus. Now balance them, 3, 4, 3, 12, 4, 2, 8, 8 to 10. If I put here 4 and if I put here 2. Now what is the number of oxygen here? 4, 3, 12. 4 to 8 to 10 to 12 hydrogen H plus. Clear? Now here is Mn. What is the Mn? Mn in MnO4. Mn is in what, which oxidation state? 4 to 8 plus 6 oxidation state. Let me check once. X plus minus 2 into 4 is equal to minus 2. X minus 8 is equal to minus 2. X is equal to minus 8 plus minus 2 plus 8. 6 oxidation state. But if I talk about MnO4, here Mn is plus 4 oxidation state. 6 converted to plus 4, that is reduction take place. Now if I talk about MnO4 minus, here Mn is plus 7. Now here the oxidation state first increases, again the oxidation state decreases. So the same substance undergo both oxidation and reduction. That is, the metal atom, the atom in the particular molecule undergoes both oxidation and reduction, and this is known as, my friend, disproportionation reaction. Similarly, if I write here CrO4 3 minus H plus, that is, it gives you, my friend, CrO4 2 minus Cr3 plus plus H2O. Clear to you? Now balance here, that is 3 8. Clear? Now put here 2. Now check out 4 3 12, 4 2 8, 8 and 4 12. Completely balanced. Now check it out. Here in CrO4 minus, chromium has oxidation state. Tell me, that is 4 to 8. That is 5. Yes, plus 5 oxidation state. And what about CrO4 2 minus? In CrO4 2 minus, that is plus 6, and here plus 3. Look at, plus 5 increases to plus 6, plus 5 decreases to plus 3. That is, same substance undergo oxidation as well as reduction, and this is known as, my friend, disproportionation reaction. Am I right? Yes sir, you are absolutely right. Now I am going to rub this part, my friend, and we'll discuss the next question. Wait for a moment. Question number 7. This is very easy and descriptive question. What is the lowest oxide of transition metal is basic and the highest is acidic? As we know, if I write here MnO, if the percentage, and write here Mn2O7, look at what I am telling. Here Mn is plus 2 oxidation state and here Mn is plus 7 oxidation state. What do we observe? This one has basic nature, but this one as, my friend, acidic nature. What it says, if the oxidation state increases, that is the acidic nature increases. That means to say, that is here the ionic character more, here the ionic character less. If the ionic character less, then basic character decreases and acidic character increases, because if ionic character decreases, the covalent character increases, and covalent character somewhat tends to moving towards the non-metallic character, and non-metallic nature if dominating, then what will happen? Non-metal oxides are acidic in nature, my friend. These are not non-metal. The general trend, if the percentage of oxygen increases or the oxidation state of the central metal atom increases, then the acidic character increases and basic character decreases. Clear to you, my friend? The next one is, a transition metal show higher oxidation state in oxide and fluoride. Why? Yes, as we know, oxygen and fluorine are small in size and have high electronegativity. Due to the small size and high electronegativity, they easily oxidize the metal, the transition metal, to its higher oxidation state. Clear? But hydrogen does not do, because hydrogen does not have the higher electron. For example, Mn2O7, for example, Cr2O7 2 minus, for example, OF6, etc. Clear to you? This is the case. Now the next one is, the highest oxidation state is exhibited in oxoanion. Oxoanion, that means to say, is very simple. That is again the involvement of oxygen, and oxygen has a small size and a high electronegativity. It oxidizes. What I am telling, my friend, it oxidizes the metal to its higher oxidation state. For example, oxoanion Cr2O7 2 minus, MnO4 minus. Clear to you? Now CrO4 3 minus, etc. all involve oxygen, and oxygen has a small size, then easily oxidized, my friend. Clear? These are the very small things and you can easily. Now I am giving you few seconds and think on this question differently, so that you can explain this thing, explain this questions in your own words, my friend. Clear? So do it. So friend, I think now you can easily solve this question. Let's move to the next one, that is the question number 8. Wait for a moment. What is given here? Listen carefully. The question here is, describe the preparation of potassium permanganate. I have discussed this thing in my lecture also. How does the acidified permanganate solution react with iron 2, SO2 and oxalic acid? Preparation, as we know, the starting material is MnO2. MnO2 when treated with KOH in presence of oxygen, clear? MnO2 when treated with Na2CO3 or we can say K2CO3, when MnO2 treated with KOH in presence of KNO3, there is a formation of K2MnO4 take place. Remember this? Yes sir. Now by disproportionation reaction, as I told you earlier, MnO4 2 minus this one, MnO4 2 minus is converted to MnO4 minus plus MnO2. This is the first method, that is, this is KMnO4, first one. Now K2MnO4 when treatment with chlorine, when treatment with carbon dioxide, when treatment with ozone, it gives you KMnO4. Remember this, it's very simple, clear? Now next one is what is given here, that is what will happen. As we know, I am moving here, as we know KMnO4 is a strong oxidizing agent. What I am telling, again I am repeating, KMnO4 is a strong oxidizing agent, and in acidic medium we know, in basic medium we people know it acts as an oxidizing agent, and equivalent weight in acidic medium we know molecular weight upon 5, because change in the oxidation state is 5. Here Mn in +7 oxidation state converted into +2 oxidation state. Now what will happen is very simple, MnO4 minus when treatment with Fe2 plus, that is iron 2 ion, what will happen? It gives you Mn 2 plus and Fe3 plus. Oxidize Fe2 plus to Fe3 plus, my friend. Similarly, when treated MnO4 minus, when treated with SO2, it gives you Mn2 plus and sulfate ion SO4 2 minus ion. Am I right? Yes sir. Now MnO4 minus when treated with oxalic acid COOH, what will happen? It converted to Mn2 plus and oxalic acid will be converted to CO2. It shows that it acts as a strong oxidizing agent in acidic medium, my friend. Clear? Now I am going to rub this part and we'll discuss the next question. Wait for a moment. As I told you earlier, this question are very simple if you have a command over the theory. Wait for a moment. Let's move to the question number 9. Now this is a complete theory based question. What is given? The transition metals and many of their compounds show paramagnetic behavior, because transition metals have partially filled d subshell. If transition metals have partially filled d subshell, that means to say they contain unpaired electron. If they have unpaired electron, that means to say they have certain value of magnetic moment. Yes. Next one, the enthalpies of atomization of transition metals are high. Again, simple thing, as we know, the strength, metallic bond strength depends upon the number of unpaired electron. Transition metals have partially filled d subshell, that is they contain unpaired electron. If the number of unpaired electron increases, the enthalpy of atomization also increases. For example, if I talk about chromium, chromium has 6 unpaired electron because the electronic configuration 3d5 4s1, so it is hard and it has high enthalpy of atomization. Now next one, transition metals generally form colored compound. It is very simple due to DD transition. The electron, that is a CFT, I will discuss in next chapter, that is degenerate orbital 1, 2, 3, 4, 5. When the ligands approaches, it break into 2 part, my friend, that is T2G and EG, and this happens only when we absorb certain radiation from light, particular visible region. And if it suppose if it take red absorb, it impart color green. Similarly, if it violet, that is it impart yellow color. This complete gives you a cycle which is known as Munsell cycle, my friend. Only DD transition. Again, transition metals and their many compounds are good catalysts. Why good catalyst? Because they have unpaired electron. They provide a surface. They have variable oxidation state. Variable oxidation, that is they help to form the intermediate compound. And they are generally solid, that is surface catalysis, that they provide a surface to proceed the reaction. Due to this reason, they act as a good catalyst, my friend. Am I right? All totally depends upon the number of unpaired electron. If you forget this question, so what to do? Explain like they contain unpaired electron, and due to unpaired electron this happens. Clear? Now let's move to the next segment. What is the next segment? What is the next question? It's very simple. Indicate the step in the preparation of K2. Chromite ore, I have discussed this thing. Chromite ore is FeO into Cr2O3, or it can be written like this, FeCr2O4. Yes, first of all, it when treated with NaOH in presence of oxygen, what will happen? It forms Na2CrO4. Na2CrO4 when treated with concentrated H2SO4. This is the step 1, and the step 2, Na2CrO4 plus H2SO4, it gives you Na2Cr2O7. This is the step 2. When Na2Cr2O7 is treated with KCl or Ki solution, it gives you, my friend, better it gives you K2Cr2O7. Better here to use KCl solution, K2Cr2O7. This is the method. Now I have discussed few minutes earlier KMnO4 from pyrolusite ore. Clear, my friend? You can easily solve. Next one, which is the last element, actinide series. As we know, actinide series contain 14 elements. Yes, sir. If it contains 14 elements, that is the first member is thorium 90 to lawrencium 103, and lawrencium has electronic configuration Rn 5f14 6d1 and 7s2, my friend. So we know the total here 3. So the oxidation state is +3, my this question. What is given? What is the last element in the series of the actinoid? Write the electronic configuration of this element. Comment on the possible, or as I told you during my lecture, that is they generally show the oxidation state, my friend, +3. So the last element, again I am repeating, lawrencium 103, Rn atomic number 86 will be 5f14 6d1 and 7s2. They do not show variable oxidation state. Why they do? Like transition metal, fixed oxidation, either general common oxidation +3, either it can show +2, very uncommon. Not it can show +1, +3, +4, +5, +6, +7, because the difference in the N-2 F cell, F subcell and N-1 D cell or NS cell is very large. Due to this reason, particular transition or intermixing not, due to this reason, it is very tough to transit this electron from here to above. Clear? Now, the next one is compare the chemistry of actinide with that of the reference of the electronic configuration and chemical reactivity. As we know, all elements of actinides are radioactive in nature. That is, they hardly exist, and they have the electronic configuration, as I told you, N-2F. Clear to you? 0 to 14, N-1D, 0 to 1, and NH2, in many books it is given, as I told you, 1 to 14 also. General common oxidation state is +3, and chemical reactivity, all member of this group have almost equal size due to actinide contraction. So the chemical reactivity is similar. They form hydroxide, they form oxide of the similar formula E2O3, because they have oxidation state 3, and they form basic oxide like hydroxide EOH all 3, but these are rare because they are, my friend, radioactive in nature. As I told you, these questions are very easy. If you have the command over the theory, then you can easily solve such kind of questions, my friend. So this all belongs to your NCERT syllabus and it will help you in your board exam preparation, my friend. So my friend, time has come, time to say bye bye. Thank you so much.